everyone. Today I'm gonna talk about very interesting and innovative articles in the field of structural design. The study proposes a connection between steel beams and concrete columns that uses smart materials to improve seismic performance. This connection is called SMAPR and combines shape memory allow bars with friction placed. What was the problem? What is it important? Traditional beam column connections can fail or suffer severe damage during an earthquake. This leaves structures unusable even if they don't collapse. The aim of the article is to design a connection that recovers after an earthquake and dissipates more energy to protect the structures. What is an SMA peer connection and how does it work? SMA stands for Shape Memory Alloy. These are materials like nickel titanium that can return to their original shape after being deformed. They are used as bars in this connection. PR refers to friction plates, metal parts that slide against each other when the structure moves. This dissipates energy and prevents damage. By combining them, we get a connection that deforms, dissipates energy, and then recovers by itself. What did the researchers do? They designed two prototypes, one with active pre-stretched SMA bars and another with passive SMA bars. Both were connected to an A-shaped steel beam and a concrete column. The connections were subjected to cyclic loads, similar to those caused by earthquakes. They evaluate stiffness, energy dissipation capacity, residual damage, and shape recovery. Key results. Both prototypes dissipated a lot of energy thanks to friction plates. The one with active SMA showed better recovery. It returned to its original position after the test. Less stiffness degradation was also observed, meaning they could keep functioning after an earthquake. They met the requirements for moment resisting connections in seismic zones. Conclusions from this article. This connection is viable and innovative proposal to improve the seismic safety of composite structures. Although full-scale testing is still needed, it offers a more resilient way of designing. The combination of smart materials with traditional design opens many possibilities in structural engineering. I found this study interesting because it represents a fusion between material technology and structural design. It made me think about how we could build structures that recover on their own, protecting both lives and its infrastructure investment. This is the first one. For the second one, I will present a very interesting study that analyzes the sustainability of urban water system in developing countries. This article focuses on Cali, Colombia, a city with an important water system but also major challenges. Problem context. Urban water systems in many developing cities suffer from several deficiencies, leaks, pollution, poor planning, and in some cases, water doesn't reach all citizens. These failures are not just technical, they also have social and environmental implications. Objective of the study. The main objective of the article is to evaluate how sustainable Cali's water system is. To do this, the study analyzes five key dimensions: environmental, social, technical, economic, and institutionally. The authors used a multi criteria decisions, making method MCDM to assess the system from multiple perspectives. Methodology. Each dimension was evaluated using a set of 39 indicators. For example, the environmental dimensions included factors like water quality and wastewater treatment. The social dimension looks at equity in water assets and citizen participation. Data sources included public databases, government documents, and interviews with stakeholders. The results show that the environmental dimension is the weakest. The Cauca River is the heavily polluted at only 40% of the city's wastewater is properly treated. In contrast, the institutional dimension performs very well. There are clear policies, solid planning, and efficient administrative structures. This means that while a city has strong institutions and clear regulatory framework, it lacks effective environmental action is not enough to have policies. There must also be investment and implementation on the ground. Based on these findings, the author recommends strengthening environmental investment, improving wastewater treatment infrastructure, and promotion education and cities' participation. They also propose applying this methodology to other cities to help them diagnose and prioritize improvements in their water system. Personally, I found this study very valuable because it connects several important fields: engineering, environmental science, economic, and social development. It reminds us that as a future civil engineers, we must think in terms of sustainable and human centered solutions. Water is a right, not a privilege, and sustainable systems are essential for healthy, equitable cities. Um, Thank you for your attention.